Hello, today we're gonna solve LeetCode problem 653, which is to sum for input is a BST. So this is a problem which is extending the LeetCode problem 1 to sum problem. And the only difference with LeetCode problem 1, number 1, is input is given as a binary search tree. So, and other things are all the same. So there are many ways to solve this problem, but one way to solve this problem is to make a list of numbers that are inside this BST, and we can basically solve the two-sum problem out of it. So let's begin. So we can retrieve the elements by any way, but for now we will just make a stack, and while stack has an element, and we would have to, of course, append the root inside the stack. This node becomes stack.pop, and if this this node has left, then we'll put the left node inside it, and the right node also. And we will also use something called numList, and whenever we popped out, we're going to put the value, this node, that value, inside this numList. Yeah, I think this will do. And after this, we will have this numList, and it just becomes a two-sum problem with this numList. So there are several ways to solve this two-sum problem, and one way is to just brute force it using 2 for loops, but we're not savages, so we're gonna use a hash set. This is not a hash set, this is a dictionary. We'll have to make it as a set, and for num in numList, we're gonna find if num is in hash set, then we're gonna return true. And if num is not in hash set, we'll have to add the value of target, which is k, minus num inside, so that the sum of 2 elements will become the target. And so if we do this with a hash set, we can just implement it by using just 1 for loop. And after this for loop runs and we don't have any problem, we can just return false. And If we submit it, it is accepted with 76 milliseconds of runtime. Okay. So this is not actually using the fact that this is a binary search tree, and one way we can actually use binary search tree is that we can put all these numbers into a list, as in we're not having an order here in any way. We can actually find that out. Not print num list. I'm going to make this a little bit bigger and run code, and you can see this is not the order. This is like doing 5, 6, 7, 3, 4, 2. So it's actually doing kind of a DFS from the right node. But we want to do an in-order traversal to sort this by binary search tree. So to do that, we'll make another function and recurse it. We'll make a function of in-order, and we're just gonna erase all this. And before that, we're just going to make a list, and because Python variables does not have like function scopes or close clause scopes, so that we can use that list inside this nested function also, and can call this in order into root.left, and after that if and we also need this clause that if root.left is not null, we can do this, and if root is not none, we can put list.append. We'll just call this numList just to avoid confusion. Append and then root.value. So this will go into root.left. So let's say we're having 5, 3, 6, 4, 2, 4, 7. This will go in order until it reaches here, and after that it'll have nothing. So it'll finally go like in this 2, it'll append the root.value into this numList, and after this we'll just simply call in order root.wait, and to test if this is working fine, we will just see if this is inside the list as 5, no, 2, 3, 4, 5, 6, 7, just assorted num list. And don't forget to call the function also. And we have an invalid syntax, so this is not a proper comment. and 2, 3, 4, 5, 6, 7. So our in order works, and after that we're gonna use a 2-pointer method which has a left and right. So right will be length of numList -1, so the last integer, and we're gonna have a while loop until left is bigger than right, which makes sense because it's gonna loop until it's like crossover, or it becomes the same index, which is not acceptable. So when numList, and we're gonna make a sum that has numList of left plus numList of right, and if sum equals k, we're just going to turn true, and else if sum is bigger than k, that means that we cannot use the right index. So this is like kind of a greedy algorithm, and we're using the smallest possible index and largest possible index, and still this is bigger than our target. So that means that the biggest target index is something we cannot use. That's like greedy, so we're just excluding it out of the picture. So we're going to make it right max equals 1, else. So this means sum is smaller than the target. I really wish they don't use k and just use target, but and similarly we'll just move the left pointer to the right for 1, and after all this is over, we're gonna return false because it means until this while loop is over, we didn't find the target. And let's see if this works. It worked, and I'm going to print out this print log because it's gonna affect our runtime. And I'm not very sure why, but the one using the 2-pointer method is actually slower than using not using the BST. Both will have the big O runtime of O of n, because putting everything inside a numList would be of O of n runtime time complexity for both of the methods, and 2-pointer method would be O of n also because it's gonna iterate in the worst case. And also the toSum method we talked about will also going to be O of n, so it's O of n plus O of n, so it's O of n. So that's it for today. Have a good day. Bye.